All right, let's get right into it. We're going to tackle one of the biggest, most fundamental questions in all of AI. You see these incredible things that AI can do, and you have to wonder, did it actually learn how to do that, or did it just get really, really good at memorizing? I mean, this question gets right to the heart of what smart even means for a machine. You know, when an AI whips up some breathtaking piece of art or drafts that perfect email, it's easy to think, wow, it gets it. But does it? Is it actually understanding the task? Or is it just a world-class parrot? Just an incredibly sophisticated mimic that's just replaying patterns it's seen thousands of times before? Well, that is the puzzle we are going to unravel right now. And the key to figuring this all out, well, believe it or not, it comes from something we've all been through. Think back to your school days. It's all about the difference between cramming for a test and actually having to sit down and take it. Seriously, that simple analogy, it's the key to understanding this whole thing. Okay, so first up, let's talk about the practice material. In the AI world, we call this training data. Just think of it like this. It's all the homework, every practice problem, all the chapters in the textbook that an AI gets to study from. This is the stuff it uses to learn all the rules, to see all the patterns for a certain subject. But, and this is the absolutely crucial part, then you've got the final exam. For an AI, this is the testing data. And what is it? It's a totally new set of problems, stuff the AI has never, ever seen before. This is not another practice round. Nope, this is the moment of truth. So here's the bottom line, right? Anyone can look good on the homework, especially if they have the answers. But it's acing that final exam that proves you actually understood the material. And it is exactly, and I mean exactly, the same for an AI. We have to know it can handle problems it didn't specifically study for. Okay, so that's the idea. But how does this actually work in the real world? Like, how do developers go about creating this final exam for their AI? Well, the whole reason, the entire goal of keeping this data separate is to force the AI to truly learn. We don't want a machine that just memorizes the answers to the homework questions. That's useless. We need it to grasp the underlying patterns so it can tackle totally new situations and make the right call when it actually matters. All right, let's make this super concrete with a simple example. Imagine we want to teach an AI how to tell the difference between a cat and a dog. We'll start with a big pile of pictures, say 1,000 of them, and each one is clearly labeled cat or dog. So what do we do with those 1,000 pictures? A really common way to handle this is what's called an 80-20 split. We take 800 of those pictures, that's our homework, our training data, and the other 200, we lock them away in a vault. They are kept totally separate because that's our final exam. So during the training phase, the AI is basically in study mode. It looks at one of those 800 pictures and takes a guess. Cat. Then it gets to check the answer key. If it was wrong, it tweaks its internal logic just a little bit. And then it does it again, and again, and again, literally millions of times, getting a tiny bit smarter with every single guess. And then it's test time. And this is a whole different ballgame. The AI is shown those 200 pictures it's never laid eyes on before. It makes its guess for each one. But here's the key. It gets zero feedback. No hints, no do-overs. The learning phase is over. It can't adjust or change a thing. We are just there to grade the paper and measure how well it does. And this is exactly how we grade the AI. So let's say it gets 180 of those 200 new images right. We can say it has a 90% accuracy. Hey, that's a solid A. And that gives us real confidence that the model didn't just memorize specific images, it actually learned what cats and dogs look like in general. But what happens when this goes wrong? What happens when it only looks like the AI is learning? Well, that brings us to one of the biggest pitfalls in all of AI, something called the overfitting trap. So what is overfitting? It is the classic example of that student who memorizes every single problem from the homework, knows them backwards and forwards, and then completely bombs the final exam. Why? Because they never actually learned the concepts. The AI becomes a master memorizer, but not a master learner. And this is what that failure looks like in practice. The AI score on the training data, the homework, is amazing. Maybe it's getting close to 100%. But the second you give it that unseen test data, its accuracy just falls off a cliff. And that is the giant red flag for developers. It's the signal that tells them, nope, this AI didn't actually learn how to generalize. Now, because this overfitting trap is so common and so dangerous, you've got experts working around the clock to create better, smarter, more sophisticated final exams to make sure these AI models are actually reliable. And this whole field is moving incredibly fast. We've gone from just a simple single train test split to way more robust methods like something called cross-validation. That's basically like giving the AI a bunch of different final exams, not just one. We're also looking at much deeper metrics now, things beyond just did it get it right or wrong. And today, there's even a trend of continuously testing AI after it's been released, just to make sure it stays on track. Okay, so why does any of this technical stuff matter to you? I mean, really, why should you care? Because this whole process we've been talking about, it is the absolute foundation for building AI that we can actually trust. I mean, just think about it for a second. Without that separate, unseen final exam, how could we ever really know what an AI is capable of? We'd have no way to tell the real learners from the fakers who just memorized everything. And more importantly, we'd have absolutely no reason to trust an AI to do critical jobs like drive our cars, help diagnose diseases, or manage complex financial systems. When it all comes down to it, this simple idea of splitting data into practice and test is the single best tool we have. It's how we verify that what we're building has some form of real intelligence and isn't just a machine with a really, really powerful memory. And that brings us right back to where we started. It's really as simple and as profound as this. The training data, that's the teacher. But the testing data? That's the final judge. That's what tells us if the AI actually learned the lesson. It's the ultimate difference between just practicing and having real proof.